All right.
All your fault, man. I was on my way to bed.
Oh,
Whom do I lie?
my fault. That's weak.
Who is crawling the floors?
Get the ups. Was that a new slide you sent? And which slide deck is that? It's the, I thought it, there it is. So I think I already have it up here. See it?
You do, but that's.
Not the latest version? Okay.
Mike sent out yesterday an update, right? Send it on Gmail. I saw an update.
Yeah, well, I was,
You want it?
well,
You want it?
no, I got, well, if you can upload it, but I
Sure.
don't trust you.
You're not trust me. Yeah. Why?
No, I trust you as a person.
Yeah,
I don't trust your skills
Yeah, yeah.
this morning to get this done.
I know. We are all copying it very fine now. Yeah. Trusting that nuances will go right over my head today. Yeah. All the uploading stuff, I remember having done it once. You want it uploaded right into this materials thing, right?
Oh, that's cool.
So Alvaro,
You're here.
Yes,
And not because you have to be.
yes, I'm very strict grooming of what I'm interested in, right?
Wow, I'm honored.
and we didn't pass the mark. You decided we can be left alone. Right.
Sorry?
And we didn't pass the mark. You decided we cannot be safely left alone.
Oh, no, no, I need to be slow. No.
It's like I've seen-
Before we start doing something.
That's the materials right here?
Yeah,
That's where you want it.
well, you uploaded it?
I can upload it.
You're not logged in yet. We'll let you.
I am here. But I
And
can,
this one said I didn't have permission. How did, I'm logged in.
I don't have an upload button.
Upload revision. You don't have permission to upload slides to this section, although I upload the first ones.
You're gonna fudge it. You're gonna
Ah,
fudge it. Make it up as you go. Sorry.
Fudge it.
I'll take notes on
We got a minute taker right here.
it. If you made it happen.
Oh, put the new slides up? Watch.
Actually, I don't even care if you put it up, just long as they're up.
It's not the volunteer thing. We're recognizing volunteers.
Yeah. Look, pressure's on now, buddy. You gotta deliver because here it goes. Bam, they are uploaded the latest rev.
Excellent.
So I'm gonna reload this and then we'll sanity check for you. Because I wanna make sure you're in for these minutes. I hate to have you take the minutes, then get to your slot and come unhinged. Yeah, I'd almost care.
Okay, that can't go overboard until I plug it in.
You got a second?
Come on, get it, like, it's,
Mike, can you review?
but however, it's
No,
going.
that's not it. It's a PowerPoint.
But this is what you just mailed me, man.
Go to the next slide.
I can't, this thing is just killed.
No, that's not it.
Let me see what you mailed me.
Yeah, people lack, but it's okay.
That's weird. I just changed this. I just uploaded it. What's it say here? 9? Okay, that's weird. I just downloaded it from my upload page and it's correct. It's got this opener text. Yeah, right. I recognize it from yesterday.
So as long as that's there, that's for, as far as I'm looking at that.
So why did this?
But it doesn't matter.
Oh, it's probably still uploading. Does the conversion or something like that? It's, yeah, that's the story I'm sticking with. Because I went from my view, I'm still doing reload. All right. We'll get it done, Mike. I promise we'll get it done, man. I don't like this bar-centric scrolling. I got to document-centric. And a Reddit area riff, there we go. We're in this range here.
So Torres won't be here?
No, we're-
It's just Torres.
We're at 9:30 now. We got to start. All right.
Jeffrey's will be crowd.
So we have a document, excuse me, first of all, blue sheets.
No, I'll help you, just ask me.
Blues.
So we have a note taker, do we have a jabber, scribe,
Yeah, never scribe.
jabber, scribe? Endless reaches, you know,
Get on Jabber for us to describe.
undying fame.
Come on, we got a minute taker right away. That was great. Early volunteer.
We have blood,
Who can get on Jabber for us?
we have blood, sweat and tears to offer. Come on, guys.
Lock your.
Let's go, jabber. This,
Wear your red shirt.
oh yeah, I left even the shirt. I brought the shirts. Find me on the floor. Yeah, early morning.
Jabber strap, someone. Come on. Can't go forward without it. I gotta point to somebody. But you gotta, I mean, it's a little hard to get in on a Jabber go. Who's on Jabber go? Someone? Anyone?
All right. I guess I'll
No
check.
love. Done.
Okay. I guess I'll have to jabber.
And we have a Jabber volunteer. All right. Well, who's ready for beer at 9:30 in the morning? Somebody is. All right, beer slides. I'm gonna warn you guys in front, you've been seeing this all day, right? Or all week. It's just challenging to work through this thing. All right, here we are. Welcome, Beer Working Group. That's 102. Oops. First thing wrong. Note well. Read? Noted well? Thank you. Here's our agenda today. I shifted things around a little bit based on availability of folks and discussion, kind of group things around content. And then I've added some stuff to this that just got announced, well, I guess today. I got slides from Torless about a design team in Roll and an interop test that a vendor is actually, not a vendor, excuse me, a provider is trying to put together for beer vendors. So I'll show that up in a bit. Everyone okay with the agenda? Anything missing? All right. Anyone I insulted? Give me his chance. All right. Yeah, we'll get to this one. So the fact I got to scroll back, I'm going to be complaining about this all morning. Sorry. So first up, multicast and HTTP. I sent an email out. Yeah, I shifted things around. I sent the mail out. Is that all right? Good. I'm glad you're here.
That's fine.
Yeah, thank you. Thank you. Honestly, I wanted people to like fresh coffee to have this conversation because I'm excited about this. It's probably not on. It's the morning thing. And feel free to point me down. I think we should get headpieces and like dance around.
Hello. Okay. Good morning, everybody. I'm Debashish Prakasta, and I'll be presenting on behalf of my co-authors listed there. So this is the draft Bier multicast overlay for HTTP response. If we go to the next slide, please.
Trying to get slides going. There we go.
Okay, thank you. So this draft is basically kind of if I recap, it is based on a previous draft, the multicast HTTP using Bier, which describes an use case in the use case document, which is listed there. And in this previous or earlier draft, we described some of the required functional elements, such as the PCE and the service router, and also there was some suggested interactions that was described in that earlier draft. If we go to the next slide, please. Now, in this draft, we basically took what was described there and tried to kind of go into a little bit details. So in this draft, we have just started off with a reference architecture to realize this use case over Bier. So it is a more like an overlay layer on top of on Bier. And as this diagram shows, there are certain this overlay is realized by is formed by the ingress routers and the egress routers, BFIR and BFER, and also some the additional functions such as the service handler and the path computation elements. The interesting thing is this the BFIR, the ingress router and egress routers are kind of combined with this additional functionality, which we call service handler, and these are marked in these red boxes. And also the PCE, the path computation element, is kind of jointly shown as the green box with the Bier TE. So which kind of basically which kind of sends or helps configure some of these red boxes, which we call them as NAPs, the client-side NAPs and server-side NAPs.
So can I ask a question? This is Greg from Cisco. You show Bier TE here in the PCE. Is TE the expected requirement, or you just threw that in as a?
Yeah, it's just a possibility. Like it is not a requirement.
Okay.
It can work
with traditional Bier.
well, yeah.
Okay. So with the what would the PCE do? If
Yeah, we have the details listed if you go down. Yeah, yeah. The next slide. So in this draft, we also tried to compare that if we want to realize this use case over IP multicast, then how can this be realized, and what are some of the the operational details, and what kind of problems are there. So in this draft, we describe the realization of this use case over IP multicast, and we basically show the operations in terms of the support that this overlay will require to create these groups, maintaining the group states, and also the signaling, IGMP signaling to join these multicast groups are described. Now, one of the issue with this realization of this use case over IPMC is that in certain scenarios where there are a few number of receivers, what we basically can see is that because when a video is encoded in multiple rates, there may be some of the bit rates which may not be required and dropped unnecessarily. So there is a wastage. And also, we anticipate that there may be a high rate of signaling, the TIM and IGMP signaling happening between from the NAPs, CNAPs, and between SNAPs. So moving forward in the next slide.
So what, Greg again? What's the assumption that the control plane, the control signal would be high with fewer receivers? It seems the opposite.
Yeah, so what we anticipate or assume is like when there are fewer number of receivers. So for example, like say a particular receiver is subscribing for or wants a particular bit rate. So generally what will happen, like it at the SNAP level, so generally what will happen from the main server, it will subscribe for all the different bit rates. So there's assumption that a multicast group will be formed for each the encoded bit rate.
Sure.
Now, on the client side, they are basically say now a client at a particular amount of time, it is basically requesting for a particular bit rate. So it subscribes for say one of the group. Now, when there's a few number of receivers, you will basically only subscribe for say one of the group there, and the other groups are they may not be joined or they don't want to join there. Now, as the say the users are basically say requesting another group, so they'll keep changing, and it has to constantly send this joining request to each of these groups. But if there is more, say if there is a large number of users, that kind of constant joining and leaving the group may not happen. So.
Well, it'll happen at the edge, but it won't propagate through the
also.
yeah,
Yeah,
that makes sense.
Yeah.
All right. Thank you.
So if we move on to the next slide. So now we go into this, after comparing with realization over IP multicast, we say that, okay, now instead of, if we have to realize this use case using Bier, and we go into certain details of the earlier functions that we described. For example, one of the function was the service handler, which was co-located with the ingress routers and the egress routers. So what the service router do, it terminates application level protocols, and again it tries to extract the URI to determine the exact path ID, and at that time it takes the help of this PCE. So this PCE, what it does, it keeps track of all these service execution points and knows how to reach them. And as we mentioned before, it can be a part of the Bier TE. And the PCE basically determines the path ID. And now what we explained what path ID is basically the origination point and the server. So basically it's the originating point and the termination point is combined, is called the path ID. And so the PCE generates this path ID, and there are certain interface functions to the BFIR where the path ID is mapped to the Bier header. And in terms of how the multicast is achieved, we follow exactly the steps that are described in the use case and now try to describe in terms of this SNAP and CNAP. So here in the server side NAP, it basically collects all those requests from the CNAP and then determines the requested block. And then as the set of synapse are basically, it collects all the requests from the synapse, and then it basically sets the bits in the Bier string and 1 bit per synapse, and then the SNAP sends that block to the Bier with the appropriate bit string being set. If we move on to the next slide, I think, so here we try to again identify or describe some of the advantages. Is basically it eliminates this dynamic multicast signaling when you compare with the IP multicast scenario. And also one of the things is it avoids sending any unnecessary data block within the IP multicast solution. And also another thing is on the SNAP side, now we can wait to collect all these requests and wait certain amount of time. We can basically configure that and then send a multicast response to all the clients that are requesting for that that send the request. And if we go to the next slide, I think that's most of the things. Yeah. So that's the end of the presentation. So now in this, just the next step, like we are basically suggesting to include maybe an additional applicability statement in documenting how a Bier can be applied to aggregate the HTTP responses. And we basically try to see that we can also elaborate on this solution to support the application statement as our next step. So I think that's the end of the presentation.
So Tony here, 2 observations. One is that even if you coalesce this request, a Bier domain gives you no penalty if you decide to do a one-on-one with the receivers before you actually cut them to like a, because
There's no state cost.
there is no state cost. You can talk to the guy just using 1 bit, 1 for 1 before you coalesce this thing, and then you cut him over on the group send. Just as an idea, because Bier is unusual. Right.
Okay.
And the second one is, so the draft still doesn't describe in gory details how HTTP has been banned to deal with this kind of multicast. But because you actually build the whole thing over PIM, I understand that all the overlay details have been pretty much already figured out. So I don't think it needs to be described. It's just an observation having read it. The draft is much, much clearer. But how the magic of the HTTP is done is still not described, which I don't think actually, is in scope of Bier anyway. Yeah.
Okay.
Rachel Huang from Huawei. Are you involved in the, the project called MABR in DVB? Are you familiar with that? Actually, I'm following that project also. We have some work in BBF that's working on, how to use multicast to deliver the HTTP streaming-based live video. So basically, the architecture is similar to the one you described here. So in the edge, they have devices to convert unicards into multicast, and in the server side, it also have unicast to multicast function located in the server side. So that's basically the whole. I think the use case actually they are doing it in the application layer. They're using current multicast capability in the network existing, like a PIM IGMP, right? They are doing something in the application layer, for example, to define the how the packet format will be look like in the multicast streams, and also they define the control level, like signaling protocols or interfaces like this. So I think this work is quite similar to that one, and I think from the requirements you describe here, I don't think in the data plan Bier should make any first change or something, but it might be useful for Bier to be used in that case. So I think maybe a guideline to describe how this Bier could be used to support that use case might be useful. So so that's my comments.
Drafts are encouraged.
Sorry?
New drafts are encouraged. Please,
no.
I didn't bring it in.
Actually, I think one draft like this kind of draft just to describe how Bier could be used in that case will be useful. Like how the functions you describe here to be I strongly suggest that to be consistent with the framework and the use cases or something like that in the different organizations to be consistent, right? We don't have to repeat something.
Yeah, I will get the details from you.
Yeah, that's
I am not familiar with the
okay.
project. Yeah.
Okay. Rachel Huang?
Rachel.
Yeah, right.
MABR, multicast ABR. Multicast ABR.
Which is a misnomer.
Jeffrey Dong from Juniper. I'm just curious, is this a use case discussion, or is this about defining a new way to do multicast flow overlay?
It's a multicast overlay over Bier.
Right. So does this working group need to define new protocol or work on this new protocol for this flow overlay, or it's just use case discussion?
This is more like an applicability document. Okay. So how to take the use case and apply it over Bier. So that's where the overlay component comes.
Okay.
This is Greg again. So in the block diagram in your discussion, you show that the service handler and BFI and BFERs are in the same device. So from a deployment perspective, if we're talking about hardware routers, that's potentially a challenge. Getting Bier in boxes is our step one, right? Getting some service handler function in that router is probably beyond the scope of many router vendors' interests as well. So if you considered, a deployment model where either the Bier's a virtual overlay, or that the service handler function can be separated and then interfaced with any BFIR.
Okay, we we just kept the functionality together.
Okay.
Now, from the deployment perspective, we have not thought like whether you want to keep it together or you want to separate and have an interface.
Right. If that BFIR is physical router. Yeah. Then there's the challenge of. And goes to Jeffrey's question. Are we talking about just an application discussion here, or is this a protocol discussion? And if there's something unique between the service handler and the Bier domain, because they're not integrated in the same box, that's some discussion we need to talk about.
Okay. Those may be some of the details we need to capture.
No more questions? Good, we got one. We have time today, right? So this is great. I'm not pushing people through this stuff. If we're going to have a discussion, assuming we got enough coffee, let's do this.
Rashad Rahman from Cisco. So sorry, I was here late, so you guys might have discussed this. Just the use of the acronym SR is not the best in this context.
You late, and that's the best comment you can bring.
I'm sorry?
Well, honestly, that's the first thing I saw too. I'm like, what are we doing here? So if it's service handler, maybe SH?
Yeah, I know, yeah. It came from the earlier draft, actually, so.
Just throwing it out. We have no religion here.
No, you were right, but it came from the earlier draft, so.
In general, we highly discourage the use of two-letter acronyms, okay?
I'm Akbar, I'm one of the co-authors. Just to make sure I understand for the next steps, so if, Devishish, if you could go to the last,
yeah,
the last
last
page.
slide.
Yeah, so the feedback from the chairs and the working group is what, that we should continue elaborating this and it seems something good to do, or is there, okay.
Absolutely. I mean, I already had discussions about something like virtual Bier overlays because people build their own replication networks, right? With really ingress rep with replication points. And you need the control protocol, even if you don't necessarily run Bier forwarding to like synchronize all the stuff. So having this kind of document and engaging people, like we had this Huawei comment, is of very high value. That's our perception. Right?
Okay, thank you.
Absolutely. All right, more questions? Excellent.
Thank you.
Very much. And now we're on to beer PIM signaling.
You shredded it.
No, I didn't. Look, it was pre-coffee.
You just randomized.
All right, excellent. Thanks, Huma. Let me get this thing in slide mode.
So we had some great comments from the co-authors, thank you very much. Basically, the main changes here were non-technical. We did a bit of house cleaning. We moved the way that the EDR is determined on the IDPR to Appendix A. There are some examples there. That doesn't mean that there are not other ways of doing it, but this is the biggest change in the version 3 of this draft. Next slide. So as of now, we consider the solution complete, the house cleaning complete, and we are hoping to have a last call on this.
Who here's read the draft? Who feels it's ready for last call? Got some good support though. Okay, so we'll take that to the list. Thank you very much. Pardon me? I would say it was like 8 to 6. 8 read, 6 said yes. I saw 2 hands go down. We do that count again. Who's read the draft? We want numbers. All right. 4, 5, 6, 7, 8, 9. Who thinks you'd be last call? 1, 2, 3, 4, 5, 6, 7. Okay, 7 and 9.
Let me ask a side question. So first, thanks. It's much more readable. Okay, this version. No, first draft I thought completely beside the point. Now I understand what the use case is, and I understand slowly how that stuff would work. No, honestly. So who thinks that having a ref forcing the authors to make it even more readable, improve the quality, would be worth doing, right? Because I was stunned. I mean, the quality of this version versus the last version. No strong feeling? Okay, just want to ask the question.
Tony, is there anything specific that you still think needs?
Can you come to the mic with the question?
Hey, Andrew Logan, okay. Do we have somebody on the remote? That's fine.
Oh, is there someone?
Oh,
You
okay,
scream
so-
if you're on Jabber, man.
Sorry, guys, for those on the remote. Is anything specific driving that question that you want clarified, or like?
From having read it on the plane,
It's a jet lag question.
the stitching was still slightly fudged. How do I figure out the edge guy
Okay,
backwards?
let's take it offline. Like,
Yeah.
again, we're open to like any cleanup, obviously, but the last call will hopefully get.
My comment is it's not ready. Okay, people are happy with last call it. It was just for me, the jump in quality was so stunning that, we could try to pimp that, right?
Mr. Perfectionist.
Please excuse my co-chair.
Did you have a beer during your beer?
You know what, why we mean St. Paul and Catherine, right? I'm Paul, he's Catherine.
Pardon me? All right, MLD signal, no, MLD 102. Is this Stig presenting? Yeah, excellent.
Yeah, hi. So, this is a working group document, my tips go. You of course try to basic flight tips, update the draft. We updated this side. Next slide. So the document is getting close to finish. And it basically talks about how to use IETF or MLD as signal in our view. It's almost like it's simple except it's different messages and works a little bit. To this document, we added some text about MT that we will do in the document as well. Basically, there is some IGP and key responses to reports. We can pack multiple groups in the same report. So we want to ideally, know them to use so that we can get as many reports as possible within one message. Just to reduce the number of IGP messages that we need to process. That's the only change. But I have one thing that I would like to discuss. So the overlay is quite simple to use. Depends on how you implement it, but basically the no configuration at all, except for one thing, which is that the multicast group address is used for sending reports to queries. We can theoretically use the existing link of the multicast addresses for IGP, but we don't really like that because the messages are not really.
Stig, can you get please closer to the mic? The guys outside don't hear you.
So, we could potentially use the existing global multicast addresses to send queries and reports. But with Bier, it's not really a good document. If you wanted to think of Bier as an overlay where all the routers are on the same region, so that you don't really want that. You'd rather think of this as a network with multiple routers. And you would prefer to use multicast addresses that are all over the world. The ground basically says that it should be possible to
There we go.
no, it's
All right. Hopefully this works now. Yeah, I can hear. It
You're great,
sounds different
10.
now. Okay, so the draft says that the multicast addresses to use for queries and reports should be configurable, which makes sense. But it's kind of tricky to deploy this if you need to go to all the routers and configure the exact same multicast addresses on every single router. So the question is whether you think it would be useful to go to IANA and ask for either a range of addresses or just one address that can be used for this purpose. So in most cases, if people have a single Bier domain, you only need, well, two addresses, one for queries, one for reports, and that's it. And yeah, maybe potentially it could be nice to have some well-known addresses for that. If you have multiple subdomains, then we allow having multiple instances with different group addresses, but that won't be a common case, I would think. So anyway, I would like some input on whether you think well-known addresses would be useful. I could maybe say though, if you use well-known addresses, the only drawback I could think of is that if there's some misconfiguration or something, maybe, some message could go somewhere where it wasn't expected to be, and those other routers also use the same well-known address, so they will just process the message just fine. But yeah, I think it would make it a lot easier for people to deploy if they were well-known. Any thoughts on that?
This is Greg Cisco. So I guess the concern is the fact that currently these are linked local multicast addresses. We've got this domain-wide Bier domain here. The challenge really only being, as you mentioned, if something leaks. And leak would be a configuration problem, really, right? So even if you had multiple sets, multiple areas, the mask itself is going to prevent that from going outside. So the BFI RERs that are part of a given set or area will only get that message. So that multicast address is really hidden from the Bier domain.
Yeah, so I'm not that concerned about leakage either. Yeah.
So why not just use the existing addresses?
Yeah, I think it's a more like an, I don't know, architectural thing, or maybe like a purist
Sure,
thing,
because
or
you know
whatever,
it's
whether
not
that's
linked
good or
local.
not. Yeah,
But for simplicity,
yeah,
configuration, if we just mapped what we have, plug it right into the Bier domain, it'll follow
yeah,
the mask as set.
yeah.
Okay, I would lean in that direction. I think we're going to get some, some feedback about what, like you said, architectural
Yeah.
purists.
So yeah, I mean, what we can say in the draft, I think it's already there, is that you may use the link local addresses. So implementations could have that as a default,
Beautiful.
I guess.
All right.
But it also says it must be configurable.
Oh, seriously?
I think so. I should double check. But I believe we say it must be configurable. Because not everyone wants to use those addresses, I would think.
Sure.
Or we want to allow multiple subdomains, for instance.
So normally I would say that once this progresses, we'll get feedback in a larger IETF community
Yeah.
from architecture board. However, this is multicast and none of them pay attention. So the people who will be paying attention are mostly in this room. So think about this. I mean, this is something that our responsibility, I'm saying to the room in general, not just to the authors and STIG, but this is part of our role. When this stuff goes forward, IETF at large, we are kind of that bastard stepchild. People put it off scope. Oftentimes, in fact, I talked to several working groups already this week where they've taken some action to say multicast is out of scope. And I understand they shouldn't try to boil the ocean, but that doesn't mean it's off the table. And often that's what happens. They say, oh, it's out of scope, and they move along. And unless we are paying attention to the community at large, they're not getting that feedback that's needed to ensure we take architectural steps that are correct for what we think should be going forward for multi-point services.
So I guess I'm starting to wonder now about the PIM document. When you send that PIM join, you normally send it to all PIM neighbors, which is a link local address as well.
Right.
So if that is used in the PIM document, I'm not sure if that's the case, then it would make sense to do the similar thing in IGMP and say a link local is okay there as well.
Okay. Yeah, at least we track consistency.
Yeah. So I'll have a look at that and try to see if it's consistent. And if I somehow disagree with the PIM document, I'll mention that in the last call. Okay.
We have, all right. Are you the next one?
I think I'm the next one,
All right.
unless you, well, at least on the original agenda.
Question, Jeffrey?
Yeah, can you go back to the slide?
Sure.
So you mentioned multiple instances, example, multiple subdomains. What's the relationship between the instance and subdomains here? What is an instance here?
I think we clarified that in the last discussion we just had, that it was kind of squinting that there could be an issue, but
I guess I missed that.
I think, well, I mean, the draft isn't very clear on that. I mean, it says that you can use it for different subdomains. You could potentially use it in other cases too, but
Is it by any chance possible that here instance could be like a routing instance, like a VPN thing?
So actually that could be one possibility. So, I mean, the draft doesn't say how you do it. Maybe that's needed, but basically, when you send, you need to send, say, IGMP query out on Bier. If you have those instances, you have to decide, okay, which instance are you in? Which group address do you want to use for the query?
So yeah, if we had something like a Verif ID, something like that, or possibly, I don't know, there's in the appendix we talk about data center a bit, and maybe you could have like a different VNI or whatever, and the group address can signify basically which instance this is, because in the report itself or query itself, there's no information about that.
Okay. I guess I'll read it more closely and then maybe discuss with you offline. One thing I wanted to see is that if we could make it generic so that this could be used for VPN as well. Maybe in the MPLS VPN case, just using the VPN label in front of IGMP packet, that maybe that could, just similar to the PIN.
Well, I agree. It could be interesting to generalize it, because even if you send a query, somehow saying what instance it is, when you get data, you need to know what instance that is as well. So, yeah, sure. Thanks. Appreciate comments on that. Yeah.
Thanks, Jeffrey. And MTU.
All right, so I have this document about MTU discovery, and I could just talk about what that draft says, but I feel like people are a little bit, I don't know, either confused or in disagreement or whatever about what this MTU discovery and is it needed and stuff. And I want to just quickly say something about MTU in general and MTU discovery. Next slide, please. So I'll try to be quick because most of you know this stuff. So I want to talk a little bit about how MTU discovery works in general. What are the options we have for Bier? And we, yes, you know, we have this working group draft already that talks about probe-based path MTU discovery. And I'm proposing a different way, which is finding sort of a subdomain-wide MTU instead. But yeah, I want to talk about the general issue before going into the drafts. Next slide, please. So obviously, for an IP packet to reach its destination, it must be small enough to traverse all the links towards the destination, which is not always that easy. In the old days, and still for IPv4 often, a packet is just fragmented along its path when it's needed. But there's lots of known issues with that. Also, it's not very optimal. We might have fragmentation happening multiple times along the link, along the path, if the MTU gradually gets slower as you get closer to the destination. Another thing which is commonly done today for IPv4 and always for IPv6 is to not fragment along the path. For before you set like don't fragment flag in the packets. The idea is that the host that originates the packets need to make sure the packets are fragmented. The datagrams are fragmented, so each of the fragments are small enough. And the question then is, how do you know what is small enough? You could use a safe value. 1280 is supposed to be safe for IPv6. It's not always the case. 500 something, I guess, used to be the safe MTU for IPv4. But ideally, you want to use something larger so that you can minimize the number of packets that are sent. Basically, you don't want to fragment the datagrams into smaller pieces than you need to. So some kind of MTU discovery is useful so that the host can know the size and can maximize the size of the fragments. Okay, next slide. So, so when you do MTU discovery today for IP, what happens is, well, first of all, the idea is that applications or say TCP can know the size so they can use the optimal, I mean the MTU so they can use the optimal size. Also with Bier in particular, if you use an overlay, then the BF, the edge Bier routers, they're actually originating packets like a join prune or an IGMP report or something like that. So it's good to know the MTU also for that purpose on Bier egress or ingress routers. What happens with IP path MTU discovery is generally that if a router gets a packet that is too big, it will send an ICMP report back to the source saying it's too big and what the available MTU is. And that way the host can, over time, learn and cache what the MTU is for different destinations. This is done always for IPv6, even for IPv6 multicast, at least the spec says so. And it's sometimes done for IPv4. For Bier in particular, it would be really bad to do the in-flight fragmentation I talked about earlier. Imagine a packet travels through Bier, and in the middle of the Bier domain, the packet is suddenly too big. If you would have to decapsulate the packet, do IP fragmentation, re-encapsulate the fragments, it just wouldn't work. So what could we do instead? You could do some kind of Bier fragments, which I don't think we want to do. Basically, have some fragment ID in the Bier header and stuff. Or we could do MTU discovery with Bier and just avoid fragmentation in Bier completely. And there's a few ways you could do that. One would be similar to IP MTU discovery, perhaps, where some Bier router, if it gets a Bier packet that is too big, it could send some new Bier message or whatever to the BFIR saying our packet is too big. And the BFIR can, make the packet, do the fragmentation as needed when it encapsulates packets. That's just a possibility. No one has proposed that. Or we could do, some MTU discovery by using either, the pro-based path MTU discovery draft or what I'm proposing in this draft. Okay, next slide. So I guess I'm already moved into this piece here. So basically on say BFIR, we would like to know the MTU so that we can report back to using IP sources saying the packet is too big when we attempt to encapsulate. But we also want to know for the overlays what the MTU is. And we could use a safe value, just say maybe 1280 or 500 or whatever will always work with Bier, but it's not optimal. So if you want to use something else, you could imagine that an administrator can configure a Bier MTU statically on each router. That might work fine, maybe. Or we could discover the MTU using one of these drafts. So that the current working group document uses probes, which might work fine. My only concern is if the topology changes, you won't really know the new MTU until the next probe. So what do you do in the meantime? Do you just drop packets, or should you probe really frequently? I don't know. And the one I'm suggesting is this subdomain MTU, which is basically using the MTU or the weakest link in a domain, which is not very optimal. If you have a single link with a very small MTU, then you are in trouble, kind of. But a good thing about it is that if there is some routing change, or in general, if a link flaps, normally the MTU would not change. So there's no signaling needed, and you wouldn't drop packets for a small time just because the MTU got smaller. It's not entirely true, though. If the weakest link goes down, for instance, then the MTU could go up. The draft is suggesting having some delay there so that you don't have to, it's no harm in keep using the small MTU for a while, especially if it's just a link flap. Of course, if someone brings up a new link that becomes the new weakest link, then you would have to reduce the MTU in the domain.
Oh, Greg again, or would you have to reduce MTU? So let me boil this down from my perspective best I can here. We have a Bier domain, which should be single administrative domain. If there's an MTU mismatch, it's a configuration problem. It's not a topology change necessarily. It's not like I had a joiner in another part of the world who wasn't part of my network, and the links down there change MTU. So going back to your use case of the overlay, that's solid. The overlay can, PIM messages, they can pack to MTU. We need to know what the network is. And as an operator, I would want feedback to tell me, if something went gunny bag. So let's say topology changed because there was a new deployment within my Bier domain. They followed my procedures. They have all the deployment done. They've sent bit assignments, but someone messed up a link configuration. I wouldn't want my content to fail everywhere else because of a configuration problem somewhere. I would prefer to have some feedback that says, we'll keep forwarding the packets everywhere else, but I'm not forwarding them here anymore because it exceeded MTU on this link, and notify some alert that you have a configuration somewhere in your network. Let the operator know there's a problem and not all the customers know there's a problem.
Yeah, it depends if whether it's a configuration problem or not, though. So I'm not talking.
If it's my domain and there's a router that doesn't match my requirements, that's a configuration problem. It's a single domain, so it's a single entity making a decision. I mean, maybe I'm wrong and wave your hands, but is there an operator case where I have a network where a handful of links will be a small MTU?
Yeah, no, so, okay, no, I agree. I mean, it could be a configuration issue in the case, say, you are trying to use jumbo frames and you forget to configure it on one router.
Right.
But it could also be valid cases where you actually have a few links in your domain that for some reason just can't handle that big MTU, or some of the devices don't handle the large MTU or something.
Yeah, admittedly, I'm thinking the provider case where we've got a large overlay network that I'm running multiple services on top of them. Bier is now part of it. And in that environment, there would be a configuration problem. So I'm admitting there are deployments coming where this may be an issue. If it's an enterprise, if it was a data center, maybe. But DC should be, again, configuration. It's only really the enterprise case, or when we're crossing administrative domains, where I can see MTU issue would be a problem. But Bier shouldn't be crossing administrative domains.
So your expectation is that basically that it would be fine to statically configure the MTU on each Bier router, or you assume that whatever MTU I have locally to reach into Bier will be the same MTU as other routers are using?
I'm just saying that the response for an MTU mismatch should not impact those who aren't impacted.
Okay.
Right. So when a new link comes up or a new device comes
Yeah,
up or
yeah.
topology changes and we have an exceed problem, if we can't fragment, we
Yeah.
should only be dropping at the link where we have
Right.
the mismatch.
Okay, yeah, so that's certainly a concern with my draft, is that it's the weakest link MTU basically. So yeah, if you have one link that accidentally has a small MTU, then it will impact all the
Right.
flows.
And I think we shouldn't ensure that's the case. We should allow for a case where let that be the problem, let everyone else's packets still flow.
Yeah. Right.
Good. I like when Aaliyah squints.
Well, no, it was a very interesting conversation. I agree. I mean, I agree that this is a configuration thing most of the time, but also seems like, and now I haven't read the draft, as you probably figured, that you could have essentially the equivalent of a configuration variable, which is the minimum MTU, which is acceptable to you for using, and that will provide a bottom so that if you have a link come in that's misconfigured, everything else doesn't have to handle it. So just, you know, it has all the usefulness of anything that's thought of in 2 seconds, but that's the kind of way you might be able to mitigate the failure.
Yeah. Yeah, no, that did occur to me too. So basically you're saying, okay, I'll try to adapt to whatever I think the MTU is, but if it's less than this, then okay, I'll just use whatever minimum I accept and assume that, okay,
Must
too
be
bad
above-
if it doesn't reach everyone. Kind of.
Must be above this line to right.
Yeah, yeah. Yeah. All right, thanks. Yeah, I will certainly do that. Yeah. Yeah. So, yeah, I'm kind of curious. Maybe I should go on to the next two slides quickly.
We are, should I go past?
Let's see, you're going the wrong direction, I think.
Okay. We're on
Next slide.
4,
And next slide.
5.
And yeah, and I'll move on to the next one too.
One more?
Let me see. Yeah, I've said all of this. Let's go on.
We've gone through this. Okay.
Okay, so there were a couple of issues raised on the list, and there's an interesting question about if we try to detect this MTU, should we? So the idea in the draft, just to clarify, is that each router looks at all its local Bier interfaces and determines what is the kind of the maximum packet I can send out to all my neighbors, or the minimum, common minimum kind of all the MTUs I have locally. And then you use the IGP to tell everyone this is my local MTU kind of. And a router, like an ingress router, will then, or any router, will look at all those announced MTUs, and the minimum of those announced MTUs is the safe MTU to use in the entire domain. The question, though, that was raised is, do you announce the maximum size before or after the Bier end cap? So the draft it seems like it's a little bit ambiguous, but at least the draft tries to say that you should announce the maximum before end cap. That is basically, say, if you natively can send 1480 and the Bier end cap takes up maybe, say, 20 bytes, I don't remember, then you announce 1460 as the MTU. It's a maximum payload, like the IP packet that can go inside the Bier header canal. The problem with that, though, is that you need to anticipate what the end caps might be. So I was thinking, you know what end caps you might use for your neighbors or in this domain, but maybe the ingress router has a choice of what end cap to use. But you have just quickly, the other option is that you announce MTU available after end cap. So if it was 1480 with a MPLS label or whatever, then that's what you announce. But then the ingress router will have to look at what end cap am I going to use and subtract that to find the actual IP MTU. And that works just fine unless, I don't know if that can happen, unless the packet can somehow change end cap on the way to the destination somewhere at the board ABR or whatever.
Okay. Have you considered making this generic, independent of Bier, just along ROR?
Yeah, I know ISIS already has sub TLV or TLV perhaps for finding like an MTU for a domain. So you could maybe do something like that. I think it's useful to make it Bier specific, though, because Bier might be deployed just in parts of your network, and you want to know what you actually can send through with Bier. But yeah, we can talk about that. But yeah, certainly once you say that you announce the MTU after Bier end cap kernel, then it's sort of not Bier specific anymore.
Right, and in fact, if you just announce the generic MTU, then the Bier can still figure out everything that it needs to know.
Right. Yeah, I suppose. The only problem, though, is, let's say you have some in your IGP domain, you have some links that are pretty small that are not part of the actual Bier domain. Then they will impact what you think you can transfer via Bier, even though they are not, never going to be used with Bier end cap.
Well, this can be figured out during the SPF, right? Once you finish SPF, you know
Yeah. So you basically look at what MTU did all the routers sort of along the path announce. Yeah. Then that's going to be interesting, because then it becomes possibly more like a path MTU than a domain MTU at that point. Okay, that's good. Let's think about that.
So I was thinking a bit of my feet, because I had some discussion with people using multicast, and there may be a different flavor which we may want to treat in the OAM document, the applicability document. I don't know. One possibility would be to, for example, we understand what payload goes in the Bier frames, right? And we could look something like an IPv4 frame, look at the DF bit. And if people flip on the DF bit and we blew the MTU, we could basically send ICMP back saying, like, on this receiver set, you are blowing the MTU, because we have on the OAM, the ICMP in-band ping and so on, we have it all defined, right? So we could send it out of path, in path, and we could specify, indicate on which receiver set you blew the MTU. So we could kind of elegantly punt the stuff in the sense that if you really worry about the stuff, put it on the payload that is within the Bier frame, which you understand, and get your router vendors to look at something like a DF bit, which indicates strongly that I care when you start to drop. Because today, most people that I talk to, they solve it at application level by configuration. And then they assume the network will be okay with it. So they don't even probe into these multicast deployments, from what I understood talking to people,
Yeah, the thing is, for V4, I don't know, I think hardly anyone does like path MTU discovery, so you just have to assume it's small enough. For V6, the specs say you always should do it, but I don't think everyone actually does it. But I would say normally today when you if you do IPv6 multicast, the specs really say you always have to do path MTU discovery if it's bigger than 1280. For various tunnel types and so on, and caps today that routers do, they handle this. So I really want, Bier to handle this as well. And all we need is for the Bier ingress router doing the NCAP to have some idea what MTU to accept. So one thing is about specs. The other thing is, it's too bad if what typically I think people do is they say, okay, my host MTU is 1500, so it won't send anything bigger than that. I'll configure jumbo frames everywhere, and then, everything works fine. The only problem is you always use 1500 bytes packets, and if you're doing like 4K streaming or something, it could be great to, do something larger. So, so I think it's, not everyone maybe needs it, but I think it's very useful to have MTU discovery. So we already have a working group document though about MTU discovery. So I guess what I want to ask is it worth looking at alternatives to that? And at least my point of view is that it is, and I'm a bit concerned about just using probes for MTU because the delay I was talking about and packet drops until you discover the new MTU.
No feedback? That was a question for the room.
But yeah, at least based on the comments so far, I have several things I know I can improve in the draft, so that's great. And do you want to look into generalizing it perhaps, and how it can be used with SPF and so on? Thanks. Okay, we have a comment here. What do you think about that?
So Les Ginsburg, and I'm a co-author, so take that as in that context. For me, the fundamental question to the working group is this useful at all? I think that if it's considered useful, what we're adding value here is to somehow advertise something that makes it easier to discover the MTU specifically for Bier usage. But the more fundamental question is, should we be doing this at all? And I asked that question in the context of both drafts, the probe draft and this one. Because I think some of the comments we've received on the list for this draft apply to the probe draft as well.
Yeah. Yes. And by the way, one important thing I feel I should mention that I kind of forgot earlier is, I was talking about how if it's a topology change, when you do probing, you will drop packets until the next probe discovers the smaller MTU. But the much more common case is actually you just get a new receiver, which is the big problem with multicast. Everything is working just fine, and then randomly one new receiver joins on a smaller link, and then basically that receiver wouldn't get any packets until the next probe discovers that, the MTU is now smaller. But anyway.
So last from my side, I poked a couple of people explaining, what we're doing, and asked them what they do today, and they do nothing, application level configuration. And when I explained to them what they could do, they went like, intriguing.
Okay. Yeah. Well, PuffMTU Discovery has a long history of not working that well, which is partly also why I'm trying to come up with something simpler here.
Yet
But
we're here.
yeah, but I'm trying to come up with maybe, hopefully, better ways, or at least some of us think so. But, yeah. Anyway,
Who's read the draft? So, yeah, maybe we'll probe this discussion on the list. I like the idea that the comments relate to both drafts, so, and we'll try to bring it to an overall discussion. All right, I think we've got one in the back, right? All right. Sorry for the shift in the agenda.
Thank you. Next slide, please.
Come on.
So this is extending the PIM signaling to MLDP. Let me take a step back and actually explain the problem we're trying to solve here. So going forward, some of the tier 1 operators out there, they're trying to build the next generation converged core. Basically what this means is that they want to have a lean core from protocol point of view, just using IGP, BGP, SDN type of protocols, or segmented routing type of protocols to build this core. That said, this core will support many other type of access services like wireless, 5G, business services, verticals, etc., etc. So what that means is that they like to choose Bier for the multicast of this core because of the simplicity of Bier. I think this group did a great job making Bier extension of a IGP, and that simplifies multicast much. And this is the attractive point of Bier using in a SDN or segmented routing type of core. That said, also stitching the legacy multicast protocols on these access networks through a Bier core is challenging. The first one we tried to solve was PIM. Going forward now is MLDP, and there's going to be many others that is going to coming up, maybe point-to-multipoint RSVPT. There is these talks of 3-seed, etc., in the segmented routing and stuff that we need to solve. So basically, we need to have a solution that can stitch legacy or future SDN type of multicast technology to a Bier core. So this is one step going farther into the MPLS domain. One thing I want to make very clear right off the bat here is that we are not trying to propose to have MLDP neighboring through the Bier. So we are not trying to send MLDP signaling through the Bier core. We are trying to use the protocols that are already there to make this happen. Next slide, please. Next slide. Thank you. One more.
One more?
Thank you. We left the...
This is fairly non-deterministic.
No, this is a great... We left the diagrams just for eye candy, so I just go to the text stuff.
Gotcha. All right.
So the proposal here is very similar to the PIM signaling. Basically, the biggest point here is that we need to have a label in the Bier domain that represents a PIMZ or a point-to-multipoint LSV. That, if you want to call it Bier domain 3 label, that BTL has to be actually assigned, has to be assigned by the EBBR, and the EBBR is the same concept as the PIM signaling. It's the router, Bier router that is closest to the source. So when the EBBR assigns that label for a point-to-point multipoint LSP or for a PIMZ, then it needs to advertise it to the IBBRs, routers, Bier routers closest to the leaf, to actually say that stitch your point-to-multipoint MLD to this label so it can be unique within the Bier domain.
when that label is assigned in the Bier domain, that label needs to be signaled to the IBBR in some way. What we chose here is BGP. MPBGP, we could come up with the new PTA type and NLRI type for this specific purpose and signal this specific label to all the IBBRs that are needed. With the same token, the EBBR, just like PIM signaling, needs to track all the IBBRs that are advertising that unique FEC. So on the data pad, it can actually use that to build its Bier header and send the traffic to all the IBBR that are interested in that specific point-to-multipoint LSP. 2 slides forward, please. Thanks.
Now it's going to go an extra one.
Thank you. So from MPLS point of view, all is happening on the BBRs. IBBR and EBBR is swapping or stitching, whatever the stitching means to the operator, whether it's a swap or whether it's pop and a push between the MLDP label and the assigned Bier domain label. So that's all that is happening from MPLS point of view. Now we need to somehow put that new MPLS packet on top of the Bier domain. So if you could go 2 slides forward, thank you. So from data path point of view, what will happen is that from the source, the MPLS packets will get forwarded to the BFIR or EBBR for that matter. The BFIR will swap the label with the Bier tree label. Since the BFIR has tracked all the BFERs, it will push the Bier header on top of them, just like PIM signaling, and will forward it to the BFERs. BFERs will pop the Bier header, will do a swap to the MLDP domain label, and will forward the traffic to the leaf. And we have an end-to-end MLDP connection. That's it.
This is Greg. Just to be pedantic a bit, why Bier domain tree label?
Just the name we came up. We are open to change it.
Okay. This is what, a 4-year exercise now. I've been trying to slice the term tree from people's discussion about Bier.
Okay.
Mostly because mentally we're always trying to map these SG states into Bier, and it's pulling it out from it. So if there's something specifically about a flow you're trying to label, or if you're just saying, this is the domain wide, then I'd say avoid tree.
Sounds good. We'll do that.
Thanks. Next slide.
No, I think we are done. Or is there another one? No, question first. Yes.
Okay, so there has been some discussions on the mailing list and offline. I just want to say that, again, that the MLDP over a core that does not run MLDP itself, that's already been specified in RFC, where the border routers of the core will run targeted LDP sessions to exchange labels for the MLDP purpose. The same thing could be done here. The only difference here is that instead of, say, RCPT, P2MP tunnel in that core, we're using a Bier quote-unquote tunnel here. Just to recap some discussions we had yesterday, the concern with that solution you guys have is that the provider may not want to run MLDP session over the through or over their core. But my comment is on that is that that MLDP targeted session between the IBBR and EBBR is not through the core; it's over the core. It's a TCP session between the IBBR and EBBR that you already run MLDP and managed by the group that responsible for MLDP. So to me, I don't think that's that's a concern. Maybe to some operators it's a concern, but I just want to point out that there's really not much difference between this and the existing solution.
Yeah, thank you. With regard to the label assignment, you're absolutely right. When it comes to both ideas, the upstream router will assign the label. The biggest difference here is how we signal it, right? You want to signal via old technology, LDP, that we are trying to deprecate in these cores, or do you want to signal with a, excuse me, a new technology that is picking up BGPLS, BGP SRT, et cetera, that these guys will move on into the future into. So just to be clear again, we feel this is a stepping stone going forward. As an example, in a mobile backhaul, going to the 5G, operators are trying to get rid of MLDP. And for them on that access network, they have no choice today but use MLDP. But to force them to run a MPLS protocol through the core where there is no desire might be a little bit of a...
To clarify, it's not through the core, it's not in the core, it's over the core. So your IBBR and EBBR, they already need to run MLDP to the access network. So over that core, between those IBBR and EBBR running MLDP, I don't think that's a problem. But again, we can talk to the operator and see.
Andrew Dolgan on Nokia. So as we talked, Jeffrey, before, it doesn't have to be a problem, but it may be a problem. It all depends how you're running your sessions and how you debugging network and things like this. So if you want to get rid of various MPLS products that you have in that core, and you don't want to deal with them, you don't want to debug them, then introducing TLDP sessions is not a solution for you. If you don't care, then TLDP is an alternative. So I don't think we're arguing that this is an alternative or not alternative. Both, to be honest, to me, both are viable solutions, and depending actually on operator and how they want to, in quotes, optimize their deployment. They may prefer this solution in one case and a more a TLDP based solution in another case.
So from my side, I'm sorry? Tony P, Chair, Juniper, friend of...
As a chair or as an individual?
A dispassionate chair. So I'm not leaning either way. I mean, I agree. I think it boils down to tooling, right? Yeah. What the operator wants is tooling. Yeah. When you sync the signaling to the data plane, which you're doing here, right, inline, we don't have any provisions for, precedents, control precedents. So that may be a good point to start to scratch your head. What will happen when you pump a lot of data over this domain and at the same time you try to signal?
It works very well with pumping that with all the MPLS stuff. So
yeah, no may not be a consideration, but that's something that comes up under high volumes when you start to signal. May deserve a sentence saying like, we do not think that is a problem. And I don't see an obvious way, how we could do that with Bier, so people can reorder. I mean, you could always go with a different subdomain and use a signaling subdomain and give it a higher preference on scheduling, right? I think we have enough.
It's a very easy local cost problem to solve, by the way. But what you're talking about, there's zero problem of marking packets properly. So you discard them differently in case of something happens in a core, but or in a part of a network that you're gonna run it. So yeah, if you don't do anything, you're exposing potentially control message tunnel through to a discards at the same level as data. But if you're implementing it like this, okay, we sell bullets, we sell guns, but we do not sell. We don't, how you use them.
Yeah, I mean, I also don't think there is any potential,
Yeah.
for major trouble we cannot resolve architecturally.
Yeah.
Just
Yeah.
laying out the landscape, right? But I think the biggest point would be tooling, right? What tooling do the operators have, and what are they preferred with? Do I just want to look at my beer frame and understand what's going on, or do I have all my tooling built, across like targeted LDP already, and that's what I run? Okay.
So just to add on top of this, if you read the draft, there is another proposal with the SDN too. So the same idea, but now instead of BGP advertising the labels to the IBBRs, SDN will actually suck up the label from the EBBR and then will download it via BGP SRTE or something like that, right? So the thoughts of the operator is going toward BGP because of the future SDN solution, et cetera, et cetera. And this is exactly why we kind of leaned toward BGP for signaling too. That's number one. But number two is no matter how we signal this, whether it's TLDP, whether it's BGP, we still need tracking of the IBBR. That draft 7060 really doesn't explain how we need to track IBBR. Just because there is a session, that doesn't mean there is a FEC for the MLDP that is advertised that we need to build the Bier header. So the Bier header really is going to be built based on the FEC and the OPEC that is advertised from the IBBR to the EBBR. So the majority of this draft is really tracking that part of the equation that we are, what is the point to multipoint LSP, what is the FEC and the OPEC, from which IBBR it's coming on. Signaling point of view, again, I think you're right, there's multiple ways of skinning the cat, and that could be argued one way or the other.
No, tracking of IBBR or EBBR is exactly similar to the PIM signaling or to the existing MLDP in-band signaling. And when you talk about how they're correlated between the FEC and other things, that's where the advantage of the existing solution comes in. It's already MLDP signaling. You already have everything already.
It's Jeffrey. It's a little bit and I don't want to make it a religious argument because this is where it's going, but it's general philosophy. Are you on a mode of introducing Bier into a network to create a domain and to simplify it part of a network? In which case, this may be a stepping. This is almost an end game, and then you simplified part and you're done. Or are you on on a way of MPLS as a control plane is, I'm gonna say a very controversial statement just for illustration purposes, please don't shoot. Is MPLS dead? And I don't wanna, and all I'm thinking about is removing it and not introducing, like if you're introducing something new and with that I'm introducing what I'm trying to remove, that's not necessarily a attractive proposition if you do not run that today. Yeah. So that's and again, different operators and different people will run different solutions. So I think the productive discussion is: do we want to have both options? And if we want to have both options, do we want to have two separate documents or one document? Or what? That to me, that would be a productive discussion.
Right. So I am definitely for simplification and definitely for moving forward. And I just want to clarify that you are still using MPLS over that core. You have that tree label. It's really just the label for that tunnel. You're still using that, and it's just the signaling side. Do you, when you say that running that LDP targeted session over the core is a concern, but I really don't see that as a concern. I agree that it will be subject to the view of a particular operator.
Let me give you an example. For security reasons, some of the ACLs do block the well-known ports, like 646. Just an example.
Great discussion. Thanks. Keep it up on the list. As a point of process, if we are going to move forward with both options, I would prefer it in the same document so that people can read it in one place, make the decision and move from there.
So sorry, I didn't catch that. What do you mean the same document? Meaning-
Well, the question came up, if we're going to have two options, do they split?
I agree. If
documentation?
we are to have two options,
Oh, okay.
then putting a little, because then we can put a little bit of a meat when what one gives you versus the other, so people can look at the black and white and elect and choose.
Perfect. Thanks. Thank you. All right. I didn't factor in the 10 minutes between slide transitions here with the new book, so bear with me. And we are, yeah, back to Jeffrey. Excellent.
So talking about moving forward, we have MPOS PHP, and now we're talking about Bier PHP. Let's look at the use case first. Let's say that you have MVP or EVPN deployment, and you have enough routers in that network that are capable of doing Bier. So you want to benefit from using Bier as the provider tunnel for the MVP or EVPN. We know how to deal with P routers that are not Bier capable, but we have always assumed that in the deployment where you want to run Bier, the edge routers will be Bier capable. But what if some of the PEs in this deployment is not Bier capable? At least during the transition phase during a prolonged transition phase. Next slide. So let's say that the PE that is not incapable of doing Bier is a egress Bier, egress PE. Now for ingress PE that is capable of doing Bier, you would have to send traffic in two ways. One is via Bier to PEs capable of doing Bier. In the meantime, if via traditional tunnels to those incapable PEs, that is complicated and it's not efficient. In some cases, it's not efficient. But what if an incapable egress PE pretends that it supports Bier, so that we can just use Bier as the owning transportation? Now, how does that incapable PE get the deal with Bier prop packets? It can't. So it would request the upstream BFR to pop the Bier header and send the packet to itself. And that would be transparent to all other PEs. So that's the basic idea. Next slide. So how do we signal that? If a Bier incapable router pretends it supports Bier, it will just signal the Bier sub-TLVs or all those things the same as it does as a normal Bier router. But additionally, it will tell others that when you send me Bier packet, please pop off the Bier header. I just want the payload directly. And to do so, for MPOS encapsulation, it's simple. Well, I shouldn't say simple. In both cases, it's simple. But in the MPOS case, all you need to do is just that when you signal the label range base in the MPOS encapsulation, you just put the implicit null label there, just like how MPOS PHP is done. But then for non-MPOS encapsulation, we would need a explicit sub-TLV. We call it the PHP sub-TLV. Basic indicates that when you need to send packet to me, you need to pop out the Bier header. Next slide, please.
Is that the right one? It bounced to.
anyway. So there are some conditions that they need to be met to do PHP. The egress P must be able to demultiplex the payload without a Bier header. For example, if you're doing VPN, well, actually this is the VPN example. There is a label in the payload that identifies the which VPN it is for. Typically, it is an upstream assigned label, but when you pop the Bier header, you no longer have the context for that upstream assigned label. But we do have another proposal, independent of this, that VPN label can be from a global sort of it's a we called it domain-wide common block. It's very similar to sRGB. That's every router will use the same label from that common block to identify a VPN. So when you do use that label, that kind of label, it will work. And if it's not VPN case, it's just a global table, then it also works. Basically, the IP payload needs to be in the address space for the Bier routing underlay. If the payload is VXLAN or NVGRE for eVPN purpose, I wrote it should be fine here. Then I realized that in the Bier for eVPN drafts, in case of VXLAN and NVGRE, there is actually no IP header. It's just NVGRE or VXLAN header directly. So there we need to put an IP tunnel header before the penultimate hop pop the Bier header. For other payload types, we need further study. For now, we don't see a use case for others yet. So but when it comes up, we can think about that. Next slide. Now, what if the P that is incapable of doing Bier is an ingress P that needs to send traffic? That could they could just ask other capable PEs to relay the traffic for them, and that is already a mature solution for other scenarios. Basically, assisted replication in case of eVPN overlay, or for MPLS MVPN, there is this concept of virtual hub and spoke. And in eVPN MPLS, there is also a concept of virtual hub and spoke. Basically, you have hubs and spokes. The spokes will send traffic to the hub, and the hub will relay to other spokes. So if you make the hub a Bier capable PE, then the incapable PE will send traffic to the hubs or the assisting replicator, then they will relay. So we want to seek working group comments, and if if people agree that this idea is sensible, and then I think it's pretty much stable now, barring the possible comments from the working group, and then we can seek adoption at that time.
Who's read the draft? Of those hands, let's keep them in the air. 1, 2, 3, 4, 5, 6, 7. Who thinks this should be adopted? 1, 2, 3. Okay, I think we'll call the list, see how it goes. Thanks, Jeffrey.
Thanks.
We had, did you have your hand up? 4. I can't see behind me. There's someone here, I just can't tell. All right, because he's supposed to be up there. You're on, mister. You're next.
My imaginary friends be
I didn't even look at these slides, so I'm going to be hypercritical.
Okay, so I published the stuff out because there's good amount of discussions now with people interested in deploying Bier, and most of the discussion are very much brownfield deployment centered, right? And one theme is how do I mix my core with Bier and non-Bier routers? The other theme is how do I upgrade my PEs? Because the PEs is just volume, tons of those. So what I put together is pretty much migration frameworks, what people can use to actually build a hybrid core. And there's a couple of approaches. There's no judgment passed, okay? All of them have certain properties, and they depend, what the customers are comfortable with in terms of migration or rolling Bier. So I'm just laying that stuff out, and I think it is a helpful framework for discussions, right? When you structure discussion with customers, how can I get Bier into my core without forklifting the whole thing? Right. So greenfield deployments, especially on larger core, are only wishful thinking. Yeah. So I think I said already all why I wrote this draft. Okay. Next one, please. Now, what I'm showing are 3 or 4 possibilities. That's pretty much an exhaustive list after having talked, with people, and there was a lot of discussions where we were moving towards the RFC. Lots of them about flexibility to allow actually to brownfield to rolling Bier, and the main split is you can either talk about a controller-based deployment, or you can talk about IGP signaling as Bier signaling. What it boils down to is that you have to either go through something which cannot do the Bier forwarding operation, or you have to go around it, and that's your choice, what you're comfortable with. I do not talk about the Bier overlays. Bier overlays on top are those are all these things we have now, this MVPN and PIM signaling and so on. So I'm not talking about any of the stuff. The overlays are doing their own thing. Next one, please. Okay, so what do we have really is, yeah, I should have made the font. Well, I got at least colors. So the green thing is we have a controller-based solution with kind of its own axis. So I talk very quickly about that. Then we have 3 possibilities to play the IGP. So in strictest sense of the word, in the strictest sense of, what we build as technology, we don't even need anything because we have the multi-topology. I talk that basically if you're willing to deploy multi-topology, you have all the tools in a sense. But the 8279 has this section that talks about the grafting, that has certain properties. And we now have pretty much this bar degree of freedom, which allows us to run, Bier-specific computation, taking into account all possible Bier metric, and frankly, we can signal more of them if we need them and use those. So those are pretty much like the 4 different things you can talk about when you brownfield Bier. Okay, next one, please. So the first one is, and you shouldn't forget it, that the tools are here. If you are willing to deploy multi-topology, some people are, then you really don't need to do anything extra to have a brownfield deployment, because you can confine the Bier-capable routers in their own multi-topology, and that has certain properties. So yes, multi-topology has been around, has been used for a couple of purposes. It is not, like the hottest thing. Lots of people perceive it as complex. They don't want to deploy it. But if you're willing to go there, it gives you certain properties which are desirable. So if you deploy multi-topology, then you basically, and your topology is not continuous, you have to strip, these pieces together. And in multi-topology, you would do it using, some kind of tunneling, which shows up as basically L3 entities. That allows you for the unicast and multicast on your network to deviate. So you can contain your multicast, a different part of your network, or force it of certain things where you only want to have unicast. And that was one of the original drivers of 203, also to build multi-topology, because the people wanted a different RPF for multicast. They didn't want to be confined by unicast. You can built partial BFR routers, which means because multi-topology is a per interface, what you call it, attribute, you can assign certain interfaces on the router being Bier capable. That can be desirable, right? Because right now Bier is basically a router property. Either the router does Bier forwarding, it doesn't. With multi-topology, you can go towards deployment where a line card is Bier capable or a certain set of interfaces, the other are not. Which, again, it depends really on what the customer is building, what he's comfortable with, what kind of product mixing does he have. What falls out is that on multi-topology, you run pretty much standard IGP computation. So you get all the protection confined within the multi-topology. That all fall out. So you get all the IGP computation benefits. What is somewhat interesting is that if you run multiple subdomains, and you can run them over multiple different multi-topologies, don't forget, we have all that stuff very well laid out architecture. You can share interfaces between multi-topologies, and those have different metrics. So you can, by default, run traffic in two subdomains in two different parts of your network, but if one subdomain loses enough links, it may use the links of the other subdomain as protection. So there is, a multidimensional game that allows you a lot of flexibility for the price of deploying the technology. What is a disadvantage is, of course, that any kind of change in setup forces you to touch links from both sides, right, on the multi-topology. You need to configure things from both sides, which can be a disadvantage or added complexity. All right, next one. The other possibility is the 6.9 solution. I'm talking about the modified step 2, which seems more practical to me from discussions, where we basically reparenting up and then assume that there is some kind of tunneling that allows us to go from someone who is Bier capable to all the leaves which are Bier capable, basically tunneling through the routers in between which cannot forward Bier. And that, has a certain appeal in terms of simplicity, because so I talk about the case where you use a dynamic, some kind of dynamic tunneling technology, and SR is an example, LDP could be another. You don't need configuration, right? Your network is magically tunneled from everywhere to everywhere when you need it. The tunnels don't have to show up in the IGP. That's another advantage, right? So your IGP is not loaded by advertising all these L3 forwarding adjacencies, which you have with other approaches, which again can be an advantage depending on how sensitive the customer is. If he already is deploying this kind of dynamic tunneling technology on his network, they may perceive that a shortest path to the goodies. You get immediate full node protection coverage on your network, right? So if you have the nodes failing, the dynamic tunneling goes around that. Like I said, you don't have the forwarding agencies on the IGP. That can be an advantage depending on scale. At a certain point in time, just the amount of tunnels showing on IGP may be a disadvantage. What you have is, however, that when your topology is changing, right, that influencing how these dynamic tunnels are moving. So that may lead to your traffic moving to your IGP having to pick the stuff up, the forwarding decision, sorry, not the IGP, but you have to recompute all the forwarding tables and re-download them. So the dynamicity is higher than like when you have static tunnels. When you run these dynamic tunneling technologies, they mostly do not, because they're mostly stateless move on the network, they don't, something like SR, OAM is something that doesn't come with the technology necessarily. So that's something to consider. If customers are comfortable with static tunnels where they have, kind of a lot of control, they can do 1+1 protection on tunnels and so on, and they have this set of requirements, this dynamic tunneling may change the dynamics of what they used to. And this approach also forces you to forward the Bier traffic along the unicast path, which may or may not be a consideration, depend on the capacity planning, whether they're comfortable with the multicast showing anywhere where they're having unicast load, but that's an inherent property. Okay, next one. Then the bar is kind of, the most flexible solution in a sense, because you can define any kind of algorithm and take either unicast property or additional Bier property into account. And you basically compute your specific Bier tree, right? And that preconditions normally configure tunnels if you want to stitch the pieces of technology together. But you can play games like you can look, for example, at capacity or replication capacity and look at things like fan-out degree that you're comfortable with on a network. You could, ping replication points. You can pretty much do anything you want. You can diverge the unicast and multicast path where the traffic is going on your network. You can compute protections, right? So that's like the weasel thing where you can go completely Bier specific and be arbitrarily flexible, at the price of dealing with specifying this stuff and deploying the technology. Next one, please. And ultimately, we also have these controllers, right, which are omnipotent. So, quis custodiet ipsos custodes, if you get the joke, right? But when you have the controller, and that's something that I already told, I'm trying to influence the Yang model. You can push the Bierts and you can push the BIFTs. And there is actually a degree of flexibility if you think about that stuff. You can have a solution where you just push the Bierts and the router is computing the BIFTs out of it, or you can push the whole BIFTs out of the controller. And there is a subtlety here that I talk about. So a controller, in terms of computation, what it can do is even more flexible, right? Because the distributed computation still doesn't have, for example, synchronized clocks. If you have something, and those things are being done, where your multicast forwarding is dependent on the time of the day, a controller can do that for you, right? So you can download, depends on, if you can predict your multicast load very well, and you have load of it, you may actually change your multicast distribution on your network depending on the time of the day, and a controller solution can basically download the tables. So pretty much anything can be taken into account on computation, but because the controller is no farther away from the nodes, it's not a distributed solution really. You have a couple of things that you need to consider. One is that your failover time is not that dynamic. So you may want to pre-compute protection. When you download these tables, you run into the problem that you need some kind of synchronization when everybody's flipping over the table, right, at the same time. Otherwise, you may black hole. And it is desirable operationally still to signal that you're taking the controller tables, because everybody has to agree what they forward on, what kind of algorithm they're running. And this is kind of one of the things where you want to make sure that someone in the middle doesn't decide to just shoot it off using a completely different distributed computation instead of listening to the controller. Yes, I mean, and the protection can be computed on the controller and pushed down as well, which you probably want to do, because on link failures and such things, you don't have this immediate distributed computation kicking in. Next one, but I think that's it. Right, so I think that's helpful as a framework to guide brownfield approach, when customers are thinking, how do I roll out Bier? And, pick and choose what are you comfortable with. Comments? Discussions?
Yeah, let me just add to this. Some of this work came from discussions out of London. We saw a lot of ideas coming out. The intent was to have some guidance from the working group. So as stuff comes up, people can go to one location and see how we get there. Because oftentimes these solutions stand out as solutions and not as a path to, a migration path in some way.
Yeah.
So that being the case, comments?
Yeah, Mike McBride, Huawei. So I applaud you for this. This is exactly what we need in our customers that we talk to. They need this kind of help.
Yes.
So thank you. I didn't even know this existed. I haven't read it. I will do so this week. At the outset, you mentioned that overlays like MVPNs are out of scope of this document, and that's fine. I'm just thinking ahead because there are some documents that Jingrong and others are, and including myself, have been working on, and we're going to give an update here. But do you see a use for something similar, but for overlays?
You ask me, absolutely. I mean, we are rolling a transformational technology, and we start to produce too many drafts for the architects to bother, right? Generally, IETF is a swamp of drafts, like 8,000 something. Read 3,000 drafts, you understand what we talk about. That is not helpful in transforming those networks. We're dealing with people who are decision makers who have to relatively quickly, cut and run, pass judgment. And we need, for example, for overlay, I want my sections. I'm running this service on my network. Okay, how do I transform this stuff? What are my options, right? And I want it in nice soundbite. And then please give me all the gory details, how you cook the sausage and the 2 options from MLDP, right? But I want to understand, how do I transform my service from here to there? What is the technological cost? What does it buy me? So I think something like that for overlay could be superbly helpful. We have to produce marketing material now.
Yeah.
Sorry, like the techie bits are cool. Now we have to sell these things, and that basis on accessible marketing materials. So absolutely. Yeah.
So Mike, just from contributor to this work, do you see that we should integrate this and add this to scope in this document overlay?
You either do that, or you have a separate document that just focuses on overlays.
I would encourage, now from my experience talking to customers, I would encourage 2 separate ones. Those are 2 different crowds you talk about. You talk to the PE crowd running the services, and you talk to the guys running the core. And those are mostly separate set of discussions. I'm not religious. We can bundle it all up in the same thing. No, I'm not. I mean, this is very non-judgmental, and it's very important, I think.
And it could be a pretty long document, though, if you do it.
And that becomes the problem in itself, right? You throw someone 70 pages, you better have a structure where they can really pick and choose very quickly, which can be done if we have the discipline for it. But if we just start to ramble and cross-reference everything, may not become very helpful.
Okay.
Right.
Yeah.
And again, this is very non-judgmental, right? We give people these things to pick and choose from, and they will judge by themselves, find what is acceptable. If they write the checks, the correct set of products will be built, right? Religious words and like mine's better than yours are not helpful now. We have the technology at the offering. It has certain properties, and we have to make the path for people to move into the technology non-judgmental and simple, easily consumable. Yeah, that's very important at this junction, I think.
Yeah, I agree. It makes less debate also when you just include different options. These are some available options for you to choose from.
Yes.
We prefer one over another, but you can choose. I think, that's maybe a good path forward, actually.
Well, and in the document, we can articulate trade-offs and paths from those choices. So you're not sifting through these and trying to compare them. As a working group, we work together to create, gently grab them by the nose and drag them forward.
And observe that I very carefully do not talk about advantages or disadvantages. Those are just properties of what you get when you pick it up in terms of requirements and properties, what you get out of it. And may be important, not important to you, and the complexity that it brings with you may be acceptable or unacceptable for you, which is all fine. People will write checks, and that will at the end define, a small set of products what ultimately will be done. But at this point in time, having, based on religious preferences, what we think is like the coolest technology will not help us at all to roll the technology forward.
Look at shiny.
Yeah. The new and shiny is gone. Now we have to make it a value proposition.
Okay, so we'll work on an overlay document. I think that's a good path forward. It's very similar to yours.
Yes, and you see like tons of stuff is coming from ALU, huge interest to us. I mean, there's enough participants that will help to shape the document because everybody will use the same document talking to their set of customers, right?
So, good, Mike, just to apologize up front, I mean, were you in London when these issues came up? Because, okay, might not have been. What happened was the fallout from the room, a bunch of us got together, cooked this time together on a call, and this draft came out of it. Right. So if you're going to do the same thing for an overlay, I encourage you to reach out to the people who have documents that are, in the same ballpark, so we can all kind of work together on what that document should look like.
Yeah, I should have emphasized it, though this is not really even my product. We had kind of a small interim that Greg was leading, and a bunch of people, we basically chewed through the stuff, and they somehow chucked it over towards me to actually write the stuff down. Okay. All done?
Thanks.
No
All
further
right.
questions?
Next up, we're getting a little tight on time here. I think we've got about 30 minutes left for the rest of these presentations, but I think you're running all of them, right?
Okay, thank you for the
Are you going to jump?
end of the timeline. Okay, the first one is something big and something ahead, I think. MVP using segment routing and Bier for high reachability multicast deployment. Okay, next page, please.
Let me see if I can make this thing work. Hey.
So what's the problem? When deploy every service, I think the customers pay attention to the reachability because the service may span multi-area or multi-AS. Okay, thank you. Traditional multicast technology such as PIM and MLDP has a very high reachability because they only need to reach the root of some IP address. But Bier has a poor reachability. Also, we have some solutions such as segmented MVP, but it will introduce pair flow states on boundary routers. Also, Bier has a limited scope for IGP to advertise the Bier information. Also, send to many sets is something like ingress replication plus Bier. So we consider a high reachability segment routing technology plus the Bier technology for unsegmented MVP. So this is the overview of the solution. This just lists the multi-area deployment. Area 1, Area 0, and Area 2. We use in the start, in the end of the area, we use the Bier hop by hop. And we use the other part, we use Bier just over the high reachability segment routing tunnel. So the MVP can be deployed end to end without any middle routers having the pair flow states. So it's a hybrid P2MP tunnel, segment routing plus Bier, or Bier over segment routing plus Bier over Bier hop by hop. And also we have a MVP overlay to complete the whole picture. Another diagram, more realistic. We may have two ABR in one area. So in this diagram, we will use any cast Bier label in on ABR 2A and ABR 2B. So this will require the ABR 2A and ABR 2B has the same Bier label. So we use any cast Bier label. And for the use of any cast Bier label, we use sRGB label for Bier label allocation. This is the detail, including the MVP signal. First, the ABR2 and the PE 21, 22, 23 is in a IGP area, and they establish the subdomain and its forwarding table using the sRGB Bier label. And then P21, 22, 23 send the leaf AD, MAPN leaf AD message to the P11. Okay. Then all the information is got, and the P11 can send the data to ABR2, and finally to the P21, 22, 23. Here, the leaf AD will have a file of the ABR2 information. ABR2 is the anchor of the Bier replication. That is to say, from ABR2, the Bier hop by hop replication is beginning. This one, I think we will introduce in the coming draft. It's about Bier, it relies on Bier IPv6 encapsulation, but the solution is completely the same. So as I have just stated, this is something ahead and something bigger. I think we welcome your comments and suggestions.
Can you go back to this slide? Next slide. Next one. Yeah, this one.
Okay.
So what's that SR label stack for?
SR?
SR label stack in that picture. What's that for? SR label.
Okay. That is just the you can see the Bier over SR label stack very clearly. SR is SR label stack, and then the anchor Bier label, that is the ABR2 Bier label, and then the left part of the Bier header. So this, sorry.
Why do you need it?
Why need this? Because we need a high reachability. Then P11 to ABR2, no matter you span area or span multi-AS, it can reach ABR2 through the SR label stack.
The existing Bier solution does not have a problem with that, I don't think. I don't think the existing Bier solution has a problem with that.
Yes.
We may need more offline discussion on this. I don't know if you have enough time to try to figure this out here. Maybe I'll talk to you offline. And so far, I don't see why you need that SR label stack there. I can follow up with you.
Okay, SR for high reachability, Bier for bandwidth saving.
It's not clear to me. I'll follow up with you offline. Yeah.
Okay, thank you.
All right, help me move along here. Let's back up. Now, entropy.
Okay.
You doing this one, Mike?
Yeah.
All right. Not necessarily. And we can this BCP. Yes. Okay. Yeah. Go ahead and get to the. Yeah, this one. I don't think your pointer's going to work. That's fine. Yeah. No, it doesn't work with this app. So, no, I got you. No, okay. Yeah. Do it again. There it is.
Okay, very good. All right, so this is a draft that we presented in Mbondi. I still feel it's probably best to be an MBOD, but we don't care really either way if it's a useful document. But we're presenting the same thing here in this working group as well. Currently, there's a option within Bier for having a entropy to be able to be used for load balancing. It's used in a variety of other protocols for load balancing, for more deterministic load balancing, and you're able to take in an ECMP environment certain fields of a packet and create a entropy label and to do load balancing on that. We talk a little bit about data center clause networks. I don't need to go into too much detail on that. Most of us are familiar with that, but there's been a migration from a hierarchical core distribution access environment in a data center to a more horizontally scalable environment for clause so that you can easily insert port density as you need it. And so it's in this environment that we think that the Bier entropy can be useful. Because there's problems with many paths today, where you have large, long-lived elephant flows that may affect performance of smaller mouse flows and reduce efficiency of per flow load sharing. There's hash function inefficiencies, and you could have flow collisions. More flows get placed on one path over the other. Isolating faults can be difficult in existing environments, and it's non-trivial. So when Bier is deployed in multi-threaded data center networks, and again, when I mentioned this in MBOD, I assume that today there was no Bier in data center networks, but Greg corrected me that he thinks that there is deployments of Bier in data center networks. So it'd be good to get some more information about that. But an operator may want a more deterministic path. And we feel that the entropy, using bits of the entropy label in Bier will be able to help make this happen. So in that last bullet point, you can use portions of that 20-bit entropy field. For instance, bit 0 to 2 of the entropy label can represent different values and be used to select different deterministic paths. Next slide. So just real quickly, again, this is just kind of gives you an overview. You can look at this later if you want, but there's multiple stages. There's 3 stages, 5 stages, and in clause types networks. And there's northward stages and southbound stages, and there's rich ECMP. And there's problems, as I mentioned, with steering of elephant flows and path divisions when you've got different set identifiers. Next slide. So yeah, as I mentioned, then you can again use different bits of the 20-bit entropy Bier label to represent different paths, and it's similar to what is happening in other drafts, including this spring entropy label for multi-stage ECMPs. We're doing it by breaking into the 20-bit entropy Bier field. So it's, as far as we can tell, there's nothing that we're adding to any of the Bier specs. We're just utilizing, it's an application of what's already been specified. Next slide. For local convergence, again, this is very similar to, it just kind of explains what happens when you have convergence and downlinks. Next slide. And this is the forwarding procedure. We do feel that it's easier and more deterministic than the existing ECMP hashing function. So with this, we're hopeful that this is a useful document on its own. Maybe it could be a part of a larger document, I'm not sure, but because it's more of a deployment, we think that this is why it should be it could be something that could be an MBOD, and many of you are already there. Any questions about that, this draft?
You say you use part of the 20-bit entropy field. So what about the rest of that field? Are they used at all, or?
No, that's to be done, to be defined.
we can use part of the 20 bit and leave the others not used.
Elia Atlas. So I'm certainly sympathetic to wanting to have deterministic hashing, but one of the things that's critical in how hashing functions are used is putting in salt, so that if you get a flow coming in, basically all of flows coming in an interface don't end up deterministically hashing to the same path, right? You get diversity of the traffic across the different ECMP next hops, not just at this layer, but at the next one and the next one. If you don't include salt in your hashing, eventually what you end up with, if for instance you took this as described, the first hop, I know it's a 5-stage class, so it's not as, but still, the first hop, you'd say, oh, here, all the traffic's going to, this traffic's going to going across next hop 1. At the next stage, all of the traffic's coming in is going, again, it's going across next hop 1. You're not going to have the traffic necessarily going across next hop 2, 3, 4. You really need to think through, look at what the model and the systematic behavior for the traffic flowing is, consider how you're applying salt in it, and think about the problems. There's a reason that it's hard to pull the information about how traffic is hashed out of routers. And I totally get the motivation, totally understand, really agree. It would be lovely to make it easier to have the determinism, but you're going to get strange system effects if you don't think about it really carefully. And I think there's what you have described here is a little naive in some of the system impact.
Okay, we'll look at salt carefully. With Bier, it may be a little bit unique just because, you have your bit stream length, and if you exceed that bit stream length, then you've got a new path, perhaps. And that's where the set identifier comes in. So anyway, yeah, we don't want to be naive. So thank you. Yeah. Yeah. I understand. Yeah. Because we haven't had a whole lot of, yeah. Yeah. Yeah.
Yeah, so we had this discussion, with Greg upfront, like what track would that be? And at the best, it would be something like a BCP.
For which have you salt in
This particular.
Yeah. And hopefully not everybody's doing precisely the same thing, right? So they observe the structure, but everybody ends up basically spraying differently from layer to layer, and that could save you from all these, incast and completely nailed stuff you talk about. Yeah.
Sure. Yeah. And we'll include that. So if you are recommending going the BCP route, are we talking about in Mbondi or are we talking about here?
Thank you for asking. That was the question I was going to bring up next, actually. Fortunately, we've got a chair here that does them both. So I remember this conversation and what came up there, which I think we should consider in the room, but I'm not going to push the issue. If this affects forwarding of a Bier packet, it probably should take place here. And hashing, the entropy field does point to a forwarding table. So I think it should be, the work should be here.
Okay.
That's what I feel. But what's the room think about this? If this is the kind of work you think is going to impact forwarding a Bier, should it take place here or in an operational group somewhere else? Who thinks it should take place in Bier? All right. That doesn't mean we're adopting this document. It just means this is the kind of work we should be doing here. Right. Okay. Yeah. It's pretty much the room of those who are making eye contact.
Okay, fair enough.
All right.
So a follow-up question would be, okay, that's good to know that we'll just focus it on Bier then. The follow-up question would be, this particular draft, does this working group feel that this is a draft that we should work on in this working group?
Right, so there's the question. Who's read the draft? Who thinks this is work that we should pick up in the working group? All the hands pretty much stayed up. I thought I saw one or two go down.
Okay.
Let me comment to his his noises. I would prefer the conversation to be taking place in a structure like this. Whether or not it moves forward is still, that's how the working group works. If the conversation is not taking place in a document with people, then things get wild.
Yeah.
Okay. I speak Tony.
The track is an orthogonal discussion.
Yeah, very good.
Yes.
Thank you.
All right, thanks. Next up. Is this you again, Mike?
Yeah.
Well, you're just all over the map.
This will be very brief. So this is what I was referring to when Tony was talking about that framework document. I think, I haven't talked to the authors, but I'm thinking that maybe this could be a candidate there. So we just wanted to just take 2 minutes. Jinrong has presented this a few times. He's talked to many of you in great detail about this document, got a lot of good comments. Basically, we're trying to make MBPN-based beer a little bit more flexible to not only look at IGP forwarding, but also be able to introduce some new tunnel attributes, those specifically being MLDP and RCPTE, point-to-multipoint, to be able to use those as the forwarding. So we're introducing 2 new tunnel attributes to be able to allow that to happen. And along that, the document talks about migration opportunities that this solution provides to be able to migrate. Because today, MVPN providers are using MLDP and RCPTE, and we feel that to be able to transition from MVPN-based beer, it'd be good to be able to continue to be able to use that forwarding for multicast-specific paths, which MVPN beer today does not allow for. So in the change log is that since the last IETF, we removed PIM. Some of you felt that was something that we should just be avoiding altogether, so we've done that. We've removed the live protection, and so now we're simply left with MLDP built P2MP beer, RCPD built point-to-multipoint beer, the forwarding procedures of that, and then being able to bypass non-beer nodes, which was also mentioned in other drafts, including the framework draft, I believe. So that's where we're at. So it's just in the last 10 minutes, I'm kind of thinking on the fly, but it may be useful to have this document either on its own to explain it in more detail, but at a minimum include these techniques for migration into an overlay framework document. And that's probably all I need to say about that. Any comments about this draft?
From my side, I would discourage to try to fix like hybrid deployments by using overlay techniques. Layers would just start to bleed into another. And we end up with hex piling on top of hex.
Okay.
Okay, we have the overlays, and one of the big selling points is that it's just another tunnel, and the overlay signaling doesn't change. It's a big selling point, and in underlay we have enough techniques to deal with this stuff. And otherwise we'll have cross. Imagine if we start to improve the underlay technique, and the overlay is already doing stuff that realize that the underlay is doing something specific. We'll have a ball of yarn where the dependencies will basically start to generate a swamp. We won't be able to move forward. I'm a little bit pessimistic, but I've seen that happening enough times. Right?
So you're okay. Let me just respond to that.
Sorry,
So,
I have a question
sorry.
to Tony. What do you mean not change overlay? I can't understand this well.
So I see suggestion that you use some pimp signaling extensions or whatever to like figure out who is supporting beer and get around that using something like pimp signaling. I don't think that this will be productive.
Yeah, we removed
Maybe
that.
I misread.
We removed that.
Maybe
It's
I
gone.
misread.
It's gone. Yeah, so that's gone. So we're just proposing being able to not only look at IGP for the underlay forwarding, but to look at other options as well that is being currently used in MVPN. So either we stay purist and only look at IGP, or we help with transition and allow for some new tunnel attributes to allow for P2MP as well. So that's kind of where we're at. And I know there's some different opinions on that. Many people have said we're trying to transition away from these legacy type of solutions, but they are being used today and they're not that legacy.
Any more comments?
So it's maybe premature, but it's been presented enough now that it would be helpful to know whether this is work that this working group is interested in working on.
Who's read the draft? Who thinks this is something that should be adopted going forward? We had, okay, 4 of the 5. All right, note taker, note that.
Okay.
Very good. Thank you. Oh, crap.
Push back twice.
Yeah, I did. No, it's just I touched the pad and it scrolls the wrong way for my brain. I forgot when people used to do this. We're in routing, we're up here. And it's alphabetical. It's us. And we are on 6-man in cap.
Okay, this is encapsulation for Bier in 9 amperes IPv6 networks. I think this is in the recharter scope. So what's the problem? To quote the Bier architecture FC, we need to run Bier on bypass tunnel for many scenarios, such as fast reroute or bypass non-BFR. These two cases both require the Bier to run over some tunnel. The problem is when the Bier amperes encapsulation has the ability to over all kinds of amperes tunnel. But the current non-amperes Bier encapsulation can't over any tunnels. It can't even run on links except Ethernet link. So that's the problem. So the requirements, when we considering the Bier IPv6 encapsulation, we need to considering at least the following sectors. It can run on various links, and it can run on unicast SRH bypass tunnel. So the problem can be divided into 2 parts. First, the basic problem is where to put the Bier header. We have 2 options. We may have 2 options. One is to reinvent a new IPv6 extension header, but this is not recommended in IPv6. Option 2 is reuse the existing IPv6 extension header. And the next question is how can Bier run over SRH? So we check the IPv6 option. We check the existing IPv6 option one by one, and then we pick the following related IPv6 option. One is the routing header. SRH is some type of routing header, and the destination option header is the right place to put the Bier option, to put the Bier header. And the destination option header, we only use the last destination option header. That is only by the final destination only, not by every destination along a SRH path. And a consideration is the up layer header. We use IPv6 has the next header field to indicating the up layer header, And also beer header has a proto field to indicating. Here we select use the beer protocol to indicating the up layer header.
Can we
So-
go back to the slide? I have a question.
Okay.
So, forgive me, understand the use case, the problem statement. We're trying to get over to a point where you're going to be forwarding beer again. If that's the case, use the beer header. I don't see what the motivation is
okay.
by re-encoding beer somewhere else. We have a well-defined beer header.
No, this is two independent question. Two independent question. One is to have the right place to put the beer header. The other question is to how this encapsulation can run plus the SRH header. Completely
Right, but
independent.
once we've got the end of that overlay, that tunnel, it's now beer. So use the existing beer encoding at that point. It's no longer SRv6. It's no longer, it's beer.
This draft is beer IPv6 encapsulation in non-MPS. So we exclude the MPS encapsulation.
Right, but at some point, it's now at a beer native router, correct? And it's going to forward from that point on beer.
Maybe, can you go to the statement slide again? Statement slide.
Okay, this one or this one?
Where I think, okay, so I think you were talking about that when you use non-MPLS encapsulation, you cannot tunnel the beer packet. Did I read that wrong or not?
Yes, this is a part of this.
That I don't understand. That's the part I don't understand. Why you cannot tunnel beer packets there?
Okay, so see this picture. Currently, the RFC has these two encapsulation. I think the first one is the MPS. Then if we say over user link, then it has a user type, this type. And then the other is the non-MPS encapsulation. It has a fixed user type. Only support userlet.
Let's say you have a tunnel, whatever tunnel it is. Let's just say IP tunnel. As long as the tunnel can indicate what's the next payload type, that will work. I think this was discussed before, that as long as the tunnel can indicate what the payload type you have, you're all set.
Yep. Right. That's it.
We do it for leading a lot of other L2 we carry L2 frames over a lot of different tunnels. So with Bier, you have really two problems. If you want to tunnel it, you have an L2 frame. We have tons of tunneling technique for L2 frames. The only problem is the tunnel has to indicate the payload type. That's not in the scope of this group, okay?
It's another thing. L2 packet in the Bier payload, and this is Bier header over some other transport tunnel. It's different things.
Right, and you don't even need to use a layer 2 header in front of the Bier header. As long as your transport tunnel indicate that next header is a Bier header.
So you mean the Bier userlet encapsulation can over anything? You can give an example.
I forgot if the IPGRE tunnel has a payload type.
Yeah.
Okay, then.
Yeah.
But the GRE, we want to use the user type AB37.
Okay, so let me rephrase. Let's say you have whatever tunnel it is. As long as that tunnel can indicate the next payload type is a Bier header with the BIFT ID, all those things, then you're all set.
Oh yeah, Atlas. So ether type is very commonly used in a number of overlay tunneling protocols in order to describe the payload that is included. That is part of why we are using ether. We decided to use ether type here. If you take a look, for instance, at the Geneve encapsulation that is being standardized by NVO3, it includes a protocol type, and that protocol type is the ether type field. This exists in a number of different tunneling headers, specifically to have some consistency and to make it easy to include an arbitrary payload inside a packet. The fact, or inside a tunnel, the fact that it's called ether type is a fascinating detail of history, and it means that we have a very collegial relationship with IEEE to get allocations of them, but it has more general use. And you should take a look at where ether type is used in different of the RFCs and the different tunneling protocols you care about to see how you can play with it.
Okay, thank you. Okay, I think I can proceed to this for the left part. I think it. So we just this one. We present. We don't say over this over that. We say Bier IPv6 hop by hop. Okay, we use. We don't use this. We use this. We encapture the Bier header in a IPv6 destination option header, an existing IPv6 extension header, and also we use a multicast address as the destination address. So multicast address and a destination option header with Bier header to pilot the Bier hop by hop replication. So this is the half part of this draft. If you think that over tunnel, we can have some other. We can focus on this part. Okay.
Yeah. Can we move on? So to discuss the list, I think we got some good feedback to the authors about existing solutions and not modifying headers to move forward. If you can come up with hard reasons why existing solutions don't work, then we can further that work, this work. All right. And we got one more. Yeah.
Okay. This is destination to update the current Bier MAPN RFC. So what's the problem? Currently, the Bier MAPN RFC only support LIR explicit tracking when using segmented MAPN. So the problem has been stated in that RFC also, but I want to have some other point that I think very important. That is the Bier join latency. When using the LIR explicit tracking, it is very inefficient because we need to first send the multicast one by one, and then in the ingress PE, send the PIM join to CE, and then get the date from CE, and then the date drive the SPMSI AD to advertise, and then the ingress PE can respond with the LIF AD, and then the ingress PE can complete the explicit tracking. So the join latency is very bad. But that is already have very good tools of LIRPF explicit tracking that defined in the also in the draft. We can use this LIRPF explicit tracking to reduce the join latency greatly. And I think this, I will not go through detail. So what's the requirement? It's just forwarding on the ABR node to do IP lookup instead of the pure label lookup described in the current mapping Bier RFC. So the benefit is significant and the change is nothing. The change is little. We don't require any IANA codes. We don't require any new procedures. So I want everyone of the Bier know this problem, this profit, and the shortcoming of current Bier mapping.
My understanding is that you're trying to solve the problem of that in the segmentation, the ABR may have to advertise per flow label if you don't do this.
Yes.
Two comments on that. One is that resorting to do IP lookup makes problem worse because you will have more. You save the MPLS state, but you're introducing the IP states in the verbs. That's making the problem worse. Second comment is that this is not specific to Bier, and this is not specific to explicit tracking. Even if you're just using ingress replication, you have the same problem. So this is not really specific to Bier.
No, it's to Bier, I want to say. So thank you for the two comments. But I want to clear it's
We can
about
follow
Bier
up offline.
because Bier needs a pair flow states always. This is the
Think of ingress replication. Same thing. If you, especially in the EVPN case.
okay. I know you may mean current Bier mapping referred to the ingress replication. So it makes some similar, but for such a big benefit, I think it deserves the change. Okay. Also, I had discussed with the current authors of the Bier mapping, Eric Rosen, and all of them. They do admit this is a solution, and also because the draft is already in the RFC edit queue, so they don't want to change it. That
I remember that even I agree that if you don't want to do per flow label, then you can use IP lookup. I acknowledge that. Then I realized that by doing so, you are making the problem worse. Before, you're using per flow label in the MPLS table. Now you're using verbs, and in each verb you have the per SG state. Its scaling problem in the forwarding path is even worse.
but it's the benefit. I think I don't need to say any more about the benefit.
All right. Move on. Okay, so we're way over. We're cutting into lunch and cookie time. You want to see how many more slides you have left here?
So
Give a little more. This is the last one. There we go. All right.
I do think this needed your notice, and we welcome your comments on the mail list, and so we can decide, because we think this is something we need right now to code. Thank you.
Thank you. All right, blues, we got them. Everyone signed them. No one's even looking up. You go like virtually eating too? Is that what happens? All right. Thank you all. Appreciate your input. I think we got some good direction. We'll see you all on the list. And in Thailand. Get on my house. Make sure I finish the beer shirt. And you be a guy. This becomes just the I changed this. We're scaling down. No, this is important. I said.